So the first thing that we're going to do here is actually graph y equals, and I'm going to move some stuff around here a little bit, but 1/2, instead of secant, we're going to do cosine of pi x, and then plus the 3/2. And I just wrote the d over here on the right just because that's the way you're used to seeing it, but in this case it happened first. Okay. Next, we should probably find the amplitude, and I guess we already talked about d there, but again, our amplitude's 1/2, d is 3/2. So remember that d equals 3/2 is what it's going to do. It's going to scoot our graph up 3/2 units, or it'll scoot the center of the wave up 3/2 units. I'm going to sketch in actually tick marks here for 1/2, 1, 3/2, and 2, and I'll explain why in a second. All right, so this one here was 1/2, this is 1, this is 2, and so in the middle there is 3/2. So that's where the center of our wave is going to end up. And hopefully this is a straight line. Next, we need to think about the period and the phase shift. So the period should be 2 pi over b. And b for us is pi, so I'm just going to replace that b with a pi. And so this is just equal to 2, which would mean that the spacing is just that number divided by 4, which is 1/2. And then last thing, the phase shift. Well, there is no c, so we don't have a phase shift. Now, let's start thinking about what cosine looks like. Okay. Cosine of 0 is 0, right? Like, or not cosine of 0 is 0. Let me put a little sketch here of cosine. Cosine's the one that starts at the top of the wave. Looks something like this. So is what I'm trying to say is we're going to be starting at the top of the wave. So if the dotted line's the middle and the amplitude's 1/2, we're going to get scooted up that extra 1/2 unit here to 2. Okay. So we at least know we're starting there, and then we should move down and follow that cosine pattern. The only thing we're missing is we need to label our x-axis. So we want to count by halves here. So 1/2, 1, 3/2, 4, my spacing isn't quite as equal as I would like, but and since I've crammed things in here, I'm not going to write in the 1/2, 3/2, 5/2, so on. All right, and then next, let's follow that cosine pattern. So at the next quarter point, we should be to the middle. Next quarter point, we should be to the bottom of the wave. And then back up to the middle, to the top, which I think is about right there, to the middle, bottom, back to the middle, and then back to the top, somewhere in there. And so we go ahead and sketch this. And Yeah, let's sketch it. All right, and just like before, the middle of the wave, these points here, they correspond to cosine of pi x being 0, okay? And so if that's the case, that means this is where we're going to have those vertical asymptotes. Let's go ahead and sketch those in there now. All right. And lastly, we're going to copy what we did when we graphed secant and cosecant up above. Just make those U shapes on each of the peaks and valleys. So far here in the blue, we have sketched one period. Here's another half of a period. And if I want to have two full complete periods here, I could either add some partial periods here on each end. Maybe we'll do that. All right, there's a quarter of a period, and here would be another quarter of a period. So if we add all this up, that's two full periods. And let's try the last one. Find the equation of the cosecant function. Well, let's sketch in the corresponding sine or cosine function here first. I'm just writing a little dot at the tip of each one of these. And let's see where we think the middle of the wave is at. It looks like it's on the x-axis. So put in some more dots, and we'll connect these. And let's see if we can figure out what the equation for this red line is, and then we know we can come up with the one for cosecant. So it looks like sine, right? It starts at the middle of the wave, just like sine does. But it looks like the period might be a little bit different. So we know that the period is going to be what it looks like 4 pi to complete one revolution or one cycle. Okay. Well, we know that the period should be equal to 2 pi over b when we're working with sine. And so then that tells us, well then b, actually let's solve for b, let's do the work. If we're going to solve for b, we'd need to multiply both sides by b, so we get 4 pi times b equals 2 pi. And then we could divide each side here by 4 pi. And that gives us 2 pi over 4 pi, which is 1/2. Okay, so we have b. Let's see if we can figure out what a is. But I want to highlight, we've figured out one of these. So next on our list, yeah, let's look at the amplitude. What do we think a is? Well, we can't tell for sure from this picture, but it looks like it's maybe about a half. Right, it looks like the distance from the center of the wave to the top is about a half a unit. And then next we have AB, so we're on to C. Well, there's no phase shift because, once again, this starts at the middle of the wave and then goes up just like sine of x does. And there's actually no vertical shift either, right? Again, the y value that we're starting with here is 0, not something else. So we have C equals D equals 0. And if we were going to write in the red line here, that would look like y equals 1/2 sine of 1/2 x. But this actually isn't what we were looking for. We were looking for the blue one there. So we end up with y equals 1/2 cosecant of 1/2 x. And I should point one more thing out here on this last example. So when we were working on example 5, I just want to note that the red curve was y equals 1/2 cosine pi x plus 3/2, while the blue one, and maybe I'll just highlight it in blue, was what we were trying to graph, y equals 3/2 plus 1/2 secant of pi x. And that wraps up this section.